Okay, guys, so here's number 10. A triangular headscarf has sides of 54, 34, and 34. What is the area of the scarf? We'll cover, again, the word area. So, you all know what I want to say. Triangle, triangle, triangle. Okay, so we have a 54, a 34, and a 34. So I know all my sides. So we're going to use Huron's formula where we got to find little s. And this is where we're going to add all the sides and then divide by 2. So 54 plus 34 plus 34, enter, divide by 2 is 61. I'm going to write this. So here we go with the area. 61. Got the one. So 61, and then 61 minus 54. 61 minus 34. 61 minus 34. Okay. And just be careful putting this in. Times 1 minus 54. 61 minus 34. 61 minus 34. And then take your square root. I got 557.9. Okay. Oopsies. Okay, number 11 says solve the equation for all the values. 3 plus 3 tangent theta equals negative tangent theta. Okay, so here we go. So what we're going to do is we got to combine these two tangents. So the way we're going to do this is that I'm going to divide, oh, I'm so sorry, subtract 3 tangent over. So we get 4 square roots of 3 equals negative 4 tangent theta. Okay, now I'm going to divide by negative 4 because we want tangent to be by itself. And I get negative square root of 3 equals tangent. Okay, so now we can do a little bit more. So I'm going to take tangent, and we're going to rewrite it as sine over cosine. Okay, now I'm only looking for one answer, because notice in the beginning of this problem, we started with the square root of 3, right? So here you go. What I'm looking for is when does sine have a square root of 3? So we're looking for sine that has a square root of 3, and sine and cosine opposite signs. Okay, so let me pull my unit circle up. So let's see, sine, remember, is the second one. I need opposite signs, so that's going to happen in quadrants 2 and 4. Sine has to have a square root of 3, so there's one of my answers, 2 pi over 3. And then the other one over here, sine has to be opposite, so 5 pi over 3. Okay, and let me pull my thing back down, and there's your answer. Okay, that was a little bit of fun. I know. My terms are fun, and yours are all different. Okay, so number 12 is cotangent squared x minus 3 equals 0. So I'm going to add 3 over. So cotangent squared x equals 3. And so now we're going to take the square root. Notice I had to put the square root in. Equals plus or minus the square root of 3. Okay, so now we're going to do the same thing, but cotangent is going to be cosine over sine. Plus or minus the square root of 3 over 1. So this time I'm looking for when does cosine have a square root of 3, regardless whether it's positive or negative. Okay, so let me pull my thing back up. Okay, so cosine is the first one, so here's one at pi over 6. Here's another one, 5 pi over 6. Ooh, look, 7 pi over 6. Keep going around. That sign, ooh, almost made that mistake. And 11 pi over 6. Okay. Now, to know you're right, all your denominators have to be equal. Okay? So be careful there. Okay, and then 13 is 2 cosine squared x minus 4 equals negative 3. So we're going to add 4 to both sides. So we get 2 cosine squared x equals 1. We're going to divide both sides by 2. Okay, so cosine squared x is equal to 1 over 2. We got to get the square root away, so we're going to take and square root both sides. So we're going to get cosine plus or minus, because we just put the square root. Remember, the square root of 1 is 1, but we can't take the square root of 2. Okay, so then we're going to rationalize it. So we get cosine x is equal to plus or minus the square root of 2 over 2. So again, it comes down to, I don't care if it's positive or negative, but I need that square root of 2 to be the square root of 2. I mean, for cosine, yes. And I love these, because you can't mess this one up. So we got pi over 4. These are all my 4s. 3 pi over 4. 5 pi over 4. And 7 pi over 4. Okay. I hope this has helped you so far, and I'll see you on the last page. Bye, guys.